Hey guys, what's up? I'm Gabby. I'm one of your TAs this semester. I'm making this quick little video just to reintroduce or to newly introduce synthesis for those of you who are transfers, haven't taken the course before, stuff like that. Or if you just slacked last semester and you're like, nah, I don't want to learn this shit. And then you're like, alright, maybe now I gotta know it kind of deal. So I'm just going to run through the basics real quick. It shouldn't take too long. At least I don't plan on it taking too long. So let's get through this. So the first thing I want to show is the toolbox. Now, you're most likely not getting it this semester, but it is useful. Few things we want to note. This reaction right here, this guy, he's your typical E2 elimination reaction that we learned in Orgo 1. This guy you guys learned towards the end of Orgo 1, PCC. And then we also have the HBr reaction, which we later found out in the course we mainly use this for the tertiary carbons, right? When we're talking about primary and secondary carbons, you guys learned an alternative method, which was PBr3. Now, for those of you that may not remember, PBr3 is just when we go from OH to Br. However, it avoids shifting, which is what HBr does. We learned that back in carbocations and reactions and stuff. So PBr3 achieves the same goal, and we mainly try to use that when it comes to primary and secondary carbons, and we'll use HBr when it pertains to tertiary, right? So PBr3 can't be used on a tertiary carbon. That's just a quick refresher. So now let's get down to the good stuff, all right? So I'm going to start off with our cut step. Now in synthesis, we are always working backwards, okay? Keep that in mind. That's the goal of synthesis. Normally, they'll have you work backwards to 4 carbons or less. The key thing that we want to do is if they give us something, say like this, right? We're going backwards. So our arrows are drawn backwards to 4 carbons or less. So this side is our product. So we're always looking at our product sides, right? These guys over here. We don't want to look at our reactants, okay? That's something that we're going to try to avoid. So now, let's go over cutting really quick. So I'm going to use the example in the toolbox just because it's super easy. So this part of our toolbox, that's our cut step. So I'm just going to explain a little bit about what they did. You guys are responsible for the mechanism going forwards. It was actually on your first workshop quiz. So I would just be aware of it, kind of know what it does, how it works. So let's run through this guy real quick. Then we'll do like 1 or 2 examples of how to apply synthesis, and hopefully it will help you out. So with this, what I like to do is I like to label things, right? So A and B are my favorite letters. So I always try to find my OH. I will follow him to the carbon he is connected to, and I will call that carbon B. Now, anything attached to carbon B, I'm going to call A. So we'll have A1, A2, and carbon A3, right? Because they're all attached to carbon B. So when I cut, I'm only allowed to cut between A and B, and I can only cut 1 carbon away. So I'm going to choose A3 only because that's what they did. So we're going to follow suit and cut between B and A3. So what you'll notice here is that my OH became this double bonded oxygen here, right? So then this carbon was my carbon B. Likewise, A3, it was on the cut line. So A3 is my carbon that got attached to the lithium. So this is my carbon A3, and this was my carbon B. So cutting can be fairly straightforward if you take it step by step, nice and easy. And that's all we're trying to do here. We're not trying to complicate it. We're just kind of keeping things nice and easy right now. All right, so let's do a synthesis together, and we'll try to apply this a little bit. So synthesis still remains on every exam this semester, and it's always 10 points. They're not going to be this easy, but they're also not going to be super, super difficult. Work with the TAs, pay attention in lecture, that kind of stuff, and you'll get the hang of them fairly easy. Right? You guys remember them for the most part. So let's do an example real quick together. do like an exam 1 synthesis, right, for Orgo 1. Something basic. We're just trying to get the basics down right now. So remember, we're always trying to work to 4 carbons or less. So we're given something like this. And they say, okay, synthesize this compound using 4 carbons or less, right? Because that's what they typically do in a chem lab. So you're going to take a look at this and say, okay, this is my product. So if I were to come over here, I see, okay, I have a BR there. And then you say, oh wait, I have one here. So a common mistake students will use is they'll use this reaction. Now that's not going to work here because this is my reactant. And like I said earlier, we're going backwards. So we need to look for the product. Now BR as a product is right here, so we can use HBr. Now remember what I said earlier, HBr is used for tertiary carbons. This guy's a secondary carbon, so we're looking to use PBr3. Alright, and that's going to give me my OH that I'm looking for. So now you say, okay, this isn't too bad. I think I can handle it, right? Not too terrible. So then we take another look and we say, okay, I got my OH. Now this is still working on my product side. So I can't use this reaction and I can't use that reaction. I must cut. So I can cut carbons off. So remember, when we cut, we're always going to label A and B, okay? It's the easiest way to go about this kind of stuff. So we start at my OH. We trace them down, the carbon he's connected to. I got myself a carbon B. Anything connected to carbon B then becomes A1 and A2. And I can only cut between A and B. So if I cut on this side, where I have this pink dotted line, right? I get 2 carbons over here, and I ended up with 1, 2, 3, 4 over there. So that works, no problem. But let's take a look. If I were to cut on the other side between B and A2, I notice I have 3 over here and 3 over there. Also works just fine, not an issue. So I'll just stick with this one because it's already drawn, but it really won't matter because they're both equally correct. So I draw my backwards arrow. These backwards arrows are keys. Don't draw forwards arrows in the middle of your synthesis. So I'm going to go, all right, I have carbon B right here. Now remember, my OH becomes my double bonded oxygen, my carbonyl group. So I'm going to draw that coming off directly. Then I have 1, 2 carbons, right? I also have A2. So I'm going to draw another dot. And I'm going to say, okay, I got A2 there. And that guy's connected to 2 carbons as well. I've already used up my oxygen, so I must use my lithium atom. So this side must become my lithium. Now the key thing that we want to notice here is that this guy up top here, get a color, this guy is this piece. We're creating our own carbonyl piece in synthesis. So we don't want to see on your arrow this guy drawn in. It wouldn't make any sense because he's already there. Alright? So try to avoid that on your exam. What you do need to include that's vital to get full credit for these kind of syntheses is we want to see step 2.H2O. That guy, super duper important. Now, I'm sure what you'll notice when you look at this is you'll say, oh snap, she didn't put anything on the arrow. Why is that? How do I do that? What's going on, right? So we don't always have to write step 1, this. If you wanted to, you could. It wouldn't be a problem. So 2 other ways that we could have drawn this, which would have been equally acceptable, would be step 1 that, step 2 water, and then the lithium compound. Or we could have done step 1 with the lithium, and then thrown this guy over here. All of these would have received full credit. Without a doubt. There wouldn't have been any issue either way. You could throw a plus sign in here if you want. Doesn't matter. Just as long as we have the correct structures, we're good. Alright, so that shouldn't be too bad. Let's do another example together, and then you guys should be okay so far on synthesis. It's really not that bad of a topic, I don't think. I think it's very straightforward. If you're just learning it, the toolbox may be something useful to throw on your index card. If you don't really yet all have all the reactions down, I think the more you practice it, the easier the reactions become, personally. But like I said, this stuff really isn't all that bad. It really just takes practice to get it down. I think the hardest part is the cutting if you're newer. Um, yeah, so let's do one more real quick. Let's say we got something weird like, I don't know, something like that, right? So now you got your double bonded O. A lot of people will be quick to think, oh, I got to do this one. We can't. Why? This guy's our reactant. We're looking for a product, so we got to use this reaction here. So we're going to go PCC. Now what I notice is that my double bonded O becomes an OH. So what am I going to do? I'm going to take my double bonded O and make it an OH. Now another crucial thing about synthesis is to always count your carbons. Without a doubt, do not lose carbons in the middle of your synthesis. Alright, so we go again. We go to my double bonded oxygen, and I say, okay, let me follow him. That's B. Anything to the left of B, A1. Anything to the right of B, A2. So if I were to cut over here, I'd get 2 carbons there. 1, 2, 3, 4, 5 carbons there. Now that can pose an issue because I need 4 carbons or less. So let me see what cutting on the other side will do for me. So if I cut between B and A2, I get 1, 2, 3 carbons over here. 1, 2, 3, 4 carbons over there. That's a much better solution, so that's the guy I'm going to go with, okay? So now when I do this, I'm going to say, okie dokie. I got a few things going on here. Let's start with the basics, right? Let's start with B. B's always the easy starting part because we know that OH is going to become a double bonded O. So I'm just going to draw it down here. I got letter B, double bonded O, and that guy goes off to the left, 2 carbons. Then I have A2. That guy is going to go down, up, down, and then we just have our lithium attached. Now you would think, okay, I'm done. Great job. We're forgetting one key thing, and that would be 2-H2O. Do not forget this guy. He is crucial in this reaction. All right, we must show him at some point, somewhere. It's a must for this guy. He needs to be there. All right. Now remember, we could have also done it a few other ways to get full credit as well. We could have done 2-H2O and then had 1 dot this guy with this on top, you know, stuff like that. So it all works out to be the same. Alright, so I hope this was helpful. Just a very quick video, and I hope you guys enjoyed it, alright?